Testing microphone, 1, 2, 3. They can hear me.
Hello, good evening. Welcome to the fourth of the U.S. Department of Energy's Portsmouth site quarterly meetings that we've done through the virtual platform. Tonight we're using a different virtual platform. We're using Microsoft Teams, and wanted to thank you for making the effort to get on and finding a new way to connect in with us. And hopefully this will improve our conversation and dialogue and make it easier for us to stay engaged and keep everyone informed over what's been a kind of a crazy last 12 months, obviously, and beyond that, dealing with social distancing and keeping everyone safe. So we want to thank you for being here tonight. We have big plans for the evening. If you've attended one of these in the past, this is going to feel similar to what you've seen on previous iterations of this. We're just going to kind of shuffle the order a little bit tonight for a special one-time viewing for you. You get the one-of-a-kind treat tonight. Tonight, we're going to start our discussion with Dr. Kathy Higley, and she's going to talk to us about understanding risk and putting those numbers that we see associated with risk into context and what they mean in terms of protectiveness for human health and the environment. And so she's going to start us off tonight. I'll follow that up with Jeremy Davis, who is the acting DOE site lead for the Portsmouth site. He's going to give us a site update on what's going on with all the different projects and work going on across the 3,700 acres that make up the Portsmouth site in Piketon, Ohio. We'll follow that up with the highlight of the evening. Frank Johnston is going to talk to us about the co-located air monitoring data and the most recent data that we've had available. So that's a big deal, and why most of you are here tonight to see what's going on and make sure everything is good and above board and safe and keeping us all handy. So keeping us all out of trouble for sure. And so to Frank and his presentation here in just a little bit. Then we'll follow that up. We'll take a short break at that point, let you grab a drink of water, step away from your desktop, wherever you've got your phone, let you catch a breather for a second, take about a 5-10 minute break, and then we will come back. We'll do a little Q&A on questions submitted tonight, and then we'll ask those of our panel, and then we'll have a public comment period beyond that. So if you can go to the next slide, Donnie, we want to make sure that this is not even though it's a virtual mechanism that we're using, that there is dialogue and that there's a chance for input throughout the night, and that we want to make sure that this is a conversation that keeps going. So first and foremost, if you have questions, please you can email those to ports-demo-questions@pppo.gov. You can throw a question up on the chat, whether you're watching on YouTube or on the Teams feed. So it's a little different than what we've used in the past. So if you're not familiar with the chat in Teams, and most of your, if you're using a laptop or desktop, in the top little menu bar, there'll be a little icon. It's a little dialogue icon. You can click on that and it'll pull up your chat window, and it'll allow you to show us what's going on and ask us questions. So you can throw that in right there. Great way to test that out is if you could let us know who you are and where you're from, and where we've got folks participating tonight. On the YouTube feed, at the bottom right-hand side, there is a chat function there as well that allows you to type in, and you can share your thoughts, comments as we go throughout the night. And then we'll pull those questions up, and if we can give those tonight. If it takes a little longer, if it's a more thorough question, a little more in-depth answer, you can find those written answers available on portsdemo.com, and we'll have those up by August 5th, portsdemo.com, where you'll find answers to previous questions from our earlier meetings as well. All right, so we got the chat on YouTube, we got the chat on Microsoft Teams, we've got the email, you can send us questions, and then at the end of the night, we're going to do the public comment for anybody that wants to participate that way. All right, we got the next slide there, Donnie. All right, so as we move towards public comment, there is the opportunity where you can raise your hand at this point to order to maintain audio levels and make sure everyone can hear what's going on. Everyone's muted at this point, but if you would like to, I'll ask for you to volunteer. You can raise your hand, we'll identify you, we'll unmute you and allow you to turn on your camera if you have one that's available to make your statement to DOE at that point. We're going to ask you to keep it to 3 to 4 minutes, somewhere in that neighborhood. And again, as we've had throughout all these, we're going to keep this, even hard questions can be asked in a respectful manner, and make sure that this is for everyone. So with that, we are ready to kick off tonight's presentation. We've had Dr. Kathy Higley with us several times over the last 3-4 years in that neighborhood, and she's a wealth of knowledge and a sought-after expert in the world of managing risk and understanding risk. So we're lucky to have her with us again tonight. Kathy's going to give her presentation. She's going to sneak away for just a second, and then she hopes to be back in time for the Q&A at the end of the night. We're looking forward to having her with us. So, Dr. Higley, the floor is yours, ma'am.
Right. Thank you very much. And Eric, thank you for that kind introduction. Could I have the next slide, please? So as I was introduced, my name is Kathy Higley. I'm a professor at Oregon State University in the area of radiation protection. And I've been there since 1994 doing work in radiologically contaminated areas. I teach students radioecology, health physics, and I've been a member of a variety of national and international groups that focus on understanding the risk from radiation in particular and finding ways to quantify and control it. And I've done research in contaminated environments all around the place. Next slide. Thank you. So I'm going to kind of set the stage for the talks that are going to come tonight. And what you're going to hear is the process of deciding how to monitor, where to monitor, and the thoughts that go into that. And what you're going to learn about is that there are a variety of regulations and standards that are in place to protect people, and that it's not a one-size-fits-all kind of an approach because we manage risk differently depending on if you're a worker, if you're in your home general public life, or if you're doing something slightly different, maybe for recreation. There are standards and regulations that apply in all these situations, and they can be slightly different in what their intent is, but to still provide a level of protection. Next slide. So, for example, you're going to hear about the thoughts and the decisions that went into monitoring for airborne constituents as a product of the cleanup efforts that are going on at the site. And one of the things that I do work across a number of DOE sites and other Navy sites and such, and the thing that's very heartfelt is that people talk to each other and they learn from each other, and you'll hear some of that tonight in the talks that are presented. And so, for example, trying to figure out, well, where do you put air monitoring stations so that you can confirm that you're protecting your workers and protecting the public? And the Portsmouth site has learned from other DOE sites, and this is an example, this bullseye pattern, where they were planning to do some demolition at a site, another DOE site, and they made some predictions of what that would look like so that they could figure out where to place monitoring stations and to be able to confirm that yeah, they had bullseye patterns pretty consistent when you're doing some work and you're generating high concentrations close into the work. And so at Portsmouth, they have a combination of fixed monitors situated around which the focus is to protect the general public. But then they also have movable monitors that follow the work activity so that they can make sure that the workers are safe. And you'll hear a lot more about that in the presentations that follow mine. Next slide, please. There's a lot of science actually to the placement of these monitors. It's not just let's slap one up here and hope for the best. And one of the things that they do at these facilities is that they have really good knowledge of what the wind patterns are around the site. And this graphic that looks like a series of sort of pie charts is actually what's called a windrows, and it provides information, a visual display of the direction and the intensity of the winds over a period of time. And this is an annual one, for example. And these are sampled, and the data is aggregated and tracked on a regular basis so that in general, if you want to put monitors around your site, in general the wind is blowing, say, from the south to the north, maybe 50% of the time, and the wind speed's 3 miles an hour or something like that. So they use that data, and then they also use some calculations and some computer models to figure out what is the best place to put a monitor, say, for the public. Because if you're working and creating an elevated release, it may travel for a little distance before it comes down close enough to the ground to affect people. So there's a lot of science and thought that goes into placing these air monitors. Slide. The other thing you'll hear about is the data that's been collected on the exposure, both times and durations. And again, it's not a one-size-fits-all. We break it out into occupational exposure limits, public exposure limits, and the reason for this is that for occupational workers, is that they're going to be exposed only 40 to 60 hours a week But they tend to be a pretty healthy group of workers with a limited age of 18 to 70 years old, for example. The public manager, though, is going to assume continuous exposure because the material has gotten off the site and out into the environment. It also includes all ages and at varying risk levels. So the very young, the very old, perhaps the immune compromised. So the result is you have these different exposure limits and standards for each group. And generally the public limits are a fraction of what the occupational limits are. And it's a recognition because of the difference of these two groups that you're trying to protect. Next slide. Yeah, thank you. So you're also going to hear about what's being sampled across the site, and they'll talk about metals, they'll talk about radionuclides, some minerals, asbestos, for example, and also volatile organic compounds. And because I was trained in chemistry early in my years, I love periodic tables. So this periodic table shows you just with the black circles, those are the metals that are sampled. The reds are the radionuclides that are being sampled as well. Slide. One of the other things that has to be taken into consideration when you do environmental sampling, you know that you're sampling for constituents that come from your site potentially, but there also may be other sources of these same constituents, and so you want to do control or background samples so that you can tease out what is already in that environment versus what might be coming from other sources, whether they're natural or man-made. So metals, for example, there can be natural sources, geology, geochemical in nature, but you can also have human activity. If you've got electronics manufacturing or a coal plant or even vehicle exhaust can contribute to a signature in your air samples of metals. Same thing for radionuclides. Uranium, for example, is naturally occurring, and you can see it just because of natural outcroppings. It can also be present in fertilizers. Of course, nuclear activity provides the presence of uranium. Technetium also comes from global weapons fallout. Even though we stopped lobbing weapons into the atmosphere many decades ago, there's still a residual. And finally, other constituents. Asbestos is natural as well. And then the same thing for volatile organic compounds. Next slide, please. So with regard to radionuclides, in addition to having these natural, so the dose that people get on average in the United States of radioactivity is around 300 millirem per year, but it varies. North America up in the top left shows how the radiation dose rate varies across the country just based on a variation in geology. And so you see almost a doubling of the dose rate depending on what the underlying geology is. Is it uranium? Is it thorium? Is it high in potassium? And similarly, we get radiation from the sun and from the cosmos. In fact, there's supposed to be a big solar flare, I think, today, and we may see disruption in our Zoom calls. But usually, the higher in elevation you go, the greater the dose that you get because you don't have as much radiation shielding provided by the atmosphere. So we see about 300 millirem a year across the United States, but that can vary considerably. In addition to that, people can get around 300 millirem a year from medical exposures. Again, this is average. Somebody may get very little, others may get a considerable amount. Port site in its annual site environmental reports is required by regulation to make an estimate of what their contribution to the dose to the people off-site actually is. And if you go and look at the ACER reports, it will report that the public dose is somewhere less than a millirem per year. So it's a tiny fraction of what we normally get from natural or medical exposures. Next slide, please. So this slide is meant to sort of convey why do we come up with the dose limits and the dose guidance that we have. And so if I could ask him to advance the slide. We know from studies there are dose rates and doses where we will see really severe effects. but there are also levels where we can measure the radiation, but we don't see any sort of adverse effect in the people. And so, as I said, we know that there is this region where effects are observed. We can measure it. We can relate dose to effect. But then in the lower region where we can potentially measure or calculate dose, we have to calculate the impact using mathematical models. The natural environment falls into that range, although it's a huge variation. And we get our information from looking at information from diagnostic procedures, radiation therapy, where we're intentionally causing effects. And we also have information that comes to us from the Japanese atomic bomb survivors that are still being followed, also from impacts from the Chernobyl accident, and to a much lesser extent from Fukushima. So we collect all this data, and that's used to inform our regulations and our guidance for. And for places like Portsmouth, when you look at the levels of cleanup that are set, what you find is those cleanup levels are way below the area where any effects are expected, and we can only use calculations to even predict them. Next slide. So you'll hear again today about the process or the progress towards cleanup of the site. And the things that I'd like you to consider is that there are substantial requirements in effect that are in place meant to protect the workers, meant to protect the public, and the environment. And again, one of the things that you'll see in the next presentation is how much thought and effort has gone into before any bit of concrete was taken down or any shovel of soil was moved, to review, to analyze, to plan before anything was implemented. And that goes for picking the monitoring locations, for the safety and the relevance. All of that has been really thought out before they started deactivation, decontamination, decommissioning, and deconstruction. And ultimately, the goal is to release these sites for redevelopment for the benefit of the community. Next slide, please. So in summary, I just wanted to give you a sense about setting regulations and setting standards, and the fact that it's not a one-size-fits-all. It considers the workers, it considers the public, it considers a variety of activities. And the goal of the remediation has been, one, to think about it quite a bit before doing anything, and recognizing that while you can't eliminate all risk from the site, we reduce it to levels that are acceptable for the workers, the public, and environment, and consider risks are. And safety, as I hope you'll see in the next presentations, is always part of this conversation and consideration. So thank you, and I hope that you enjoy what's going to be presented in the next series of talks. Thank you very much.
Well, good evening, everyone. My name is Jeremy Davis. I am the acting Portsmouth site lead, and I'm going to take an opportunity to kind of update you on where we're at in the DOE cleanup mission. I'll give you guys a little bit of information about myself. I have over 20 years of experience in the nuclear industry. That has primarily been here at the Portsmouth site. I'm a lifelong resident of Pike County. I got a bachelor's degree in natural science with focus areas in biology, chemistry, and geology. Most of my experience here at the plant has been in project management, environmental compliance, hazardous waste management, and environmental program integration and facility oversight. I also hold a certified hazardous materials manager certification and a project management professional. Next slide. So I think if you are familiar with the site, some of this information will be redundant, but I do want to share with you some of the Portsmouth site history because I think it becomes important when understanding, how the cleanup mission has been framed. So it's a 3,700 acre federal site. The primary focus was uranium enrichment operations through gaseous diffusion. That started in 1954. And then the DOE cleanup mission began in 1989, with the full-scale D&D beginning in 2010. So the original purpose was during the Cold War, and focused on nuclear defense. And then after the Cold War ended, the focus was on commercial nuclear power and environmental cleanup. So right now, since 2001, the department has been focused on environmental cleanup. And then you'll see from my updates to this presentation, the full-scale decontamination and decommissioning that's been ongoing for the last little over a decade. So this also includes property transfer and reuse, and we'll talk a little bit more about that here in subsequent slides. So next slide. So what is our 10-year deactivation and demolition focus? That focus is to complete deactivation and demolition of our 3 largest facilities on site, and that is the 3 process buildings that house the gaseous diffusion equipment. So they are the X326, the X330, and the X333. I'm happy to report that the structural demolition of the 326 is complete. And then we are currently transferring the demolition debris to the on-site waste disposal facility. So the on-site waste disposal facility is the ending spot of the demolition debris, and as you'll see in later slides, it's a highly engineered facility used to house the material and safely store it in perpetuity. As a part of DOE's commitment to the cleanup here at the site, we are also excavating landfills and plumes within the perimeter road. So this excavation not only provides more land for reuse, but it also provides the necessary soils needed to prevent subsidence in the OSWDF during the placement of the debris. As I said before, digging up the landfills and plumes also allows the department to transfer more land to the local reuse organization, which is Southern Ohio Diversification Initiative, which we will probably refer to them as SODI. So next slide. So Kathy kind of alluded to this earlier when she talked about, having the benefit of lessons learned from other sites when it comes to demolition safety planning. So you'll see in this picture, one of the last sections coming down of the 326 facility. So that 326 safety planning, demolition design plan was carefully thought out. We took into consideration lessons learned from other decommissioning and demolition work that's going on across the complex at Hanford, Oak Ridge, Fernald. And then we developed that demolition design plan, which was submitted to Ohio EPA, and we received their approval to commence with the demolition activities in concurrence with that plan. So one of the initial steps is to go into the facility and remove hazards from the building to make it safe for demolition. So this facility had, as Kathy said, asbestos-containing material, processed gas equipment inside, and a lot of that material was removed from the facility to make it safe for demolition. We also focus on our trained and experienced workforce. So a lot of the folks working here have worked here for several years, dealt with radionuclides, and then we also went out to industry to look at the D&D effort as well, to get people who were well-versed in structural demolition. So we implemented several protective measures to minimize the disturbance of any residual radiological or chemical contamination of the facility. So you'll see in the picture a mist of water that was sprayed on the facility during demolition. This is a dust suppression tactic that was implemented during the demolition of the facility, and also will be implemented during the size reduction and transfer of that material to the OSWDF. You'll also see in the upper right-hand corner of the picture a pile of debris that has somewhat of a green tint to it. That green tinted material is a fixative, and that fixative was sprayed on the facility as a part of demolition as well to control the radiological and the chemical contaminants of the structural steel and other components that were left in the facility. So, those mitigation tactics help us lower, fugitive dust emissions or any other contaminants that would, escape the site. And then that water, you'll see some standing water in that picture, is collected through a berm and then treated at our water treatment facility that's specifically designed for our contaminants of concern. As a part of this demolition, we have also implemented a very robust environmental monitoring program. So we look at analytical for the water, the air, and any type of protective measures that we take to not only protect the workers but also protect our site boundary as well as our local community. Next slide. So the 326 process building demolition and cleanup began in May of 2021. The structural demolition was completed on June 10th of this year, so just not too long ago. And then that debris generated was about 135,000 cubic yards of debris. So that waste is being size reduced and then sent to the OSWDF for disposal. So one of the initial actions that was taken of the facility was to remove the transite panels from the facility, which are asbestos containing concrete panels that were on the outside of the facility. So the picture you see in the top left is stacks of those panels that have been double wrapped and are being transferred to the on-site waste disposal facility for disposal. And those items are taken to the OSWDF and placed in the bottom of each cell, and each cell is constructed in a grid to provide a safety factor for that material as it's stored. The next picture you see to the right is one of the track shears that's used to size reduce the material. And then the picture at the bottom is a pretty good aerial view of what the facility kind of looks like now. So if you are someone who's worked at the site, it is kind of a different view now from a landscape standpoint when you look across this facility and see it basically on the ground in piles. And you'll notice those piles have that green fixative applied to them. That's one of our mitigation tactics that we take after the structural demolition is complete. They put that fixative on those piles to ensure that we maintain any fugitive dust emissions or contaminant of concern emissions from those piles. Next slide. So in concert with placing that debris at the OSWDF, as I mentioned before, we need soil. So that soil is coming from our contaminated plume excavation. So that soil provides compaction in order to fill the debris into the OSWDF. There are compaction requirements, and that soil is used to construct those grids for that debris placement. So what that allows the cleanup mission to do is leave behind more acreage for site development. So I'm happy to report that the X740 plume excavation is complete. That was our first initial contaminated plume excavation that we did. They were able to deliver about 40,000 cubic yards of soil and fill to the OSWDF. Currently we are excavating the X231B plume, which if you look at the picture, you can kind of see in the green where that contaminated plume is located. That excavation is anticipated to be complete later this summer, and it will provide the remaining soil needed to place into the OSWDF the remainder of the 326 debris. Next slide. So you've heard me talk quite a bit about the on-site waste disposal facility. I do want to take an opportunity to kind of share with you the specific design requirements that were set forth when constructing the disposal facility. It has a multi-layer liner and cap system. It's designed to consolidate all that demolition debris and rubble into one centralized, footprint. So if you can imagine, there's approximately, several acres of facilities that we will consolidate into this area. The specific design, when I talk about multi-layer design, if you look at the left-hand side of the bottom right square on the graphic, you'll see that there are two high-density polyethylene liners, and there's also a clay liner, and then a protective layer placed on top of those liners to prevent any of that material from exiting that OSWDF. It also includes a pretty substantial capping system, which also includes a compacted clay cap liner and also another layer of HDPE liner on top, and then a biointrusion layer, and then another layer of soil, grass, and vegetation put on top. So this facility will accommodate more than 5 million cubic yards of waste and engineered fill from the plume excavations. So it's divided into 12 cells. It takes about 3 cells per process building. So we anticipate, we will definitely need 10 cells, 3 for each process building, and then one cell for the remaining support facilities that are on site. And then we have contingency built in for the 2 remaining cells should there be additional waste volumes on site that meet the waste acceptance criteria and can be placed in the OSWDF safely. Next slide. So that brings me to another topic that Kathy kind of mentioned initially, and that is the real-time air monitoring. So Ports has a pretty substantial air monitoring program that also includes not only the program air monitors, but also the project-specific air monitors. So we have 180 total air monitors located on and off site. We looked at things like windrows and things like that to decide where those monitoring devices would be located. So you'll see on the map, we have project air monitors, and also we also have DOE, Ohio EPA co-located air monitors, and DOE and Ohio Department of Health co-located air monitors. So those co-located air monitors that you see on the map give us the independent data that is supplied to the public to verify that what the data that we're seeing in our air monitors is consistent with those that are independently obtained. So these air monitors measure various things. They measure radiological and non-radiological particulates, things like metals, volatile organic compounds, asbestos, and Mr. Frank Johnston will be sharing with you extensively some of that data that has already been obtained during the demolition that has taken place thus far. So these results are measured at varying intervals, and as I mentioned before, that includes real time. If you give me the next slide, we're going to talk more about the real-time air monitoring. So when I say real-time air monitoring approach, it is truly a real-time monitoring approach that gives us the first line of defense. So some of those project-specific monitors include radiological, fugitive dust emissions that are measured hour upon hour. This gives us feedback to the project so they can look at the mitigation tactics that are in place during the demolition. They can use that data, not only the monitoring data, but also the weather data to ensure that we have the proper mitigation tactics in the right places at the right time. So this gives us the assurance that we need that we're limiting not only at the project-specific boundary, but also at the property boundary to ensure that any emissions will be safe and compliant. So being able to react immediately in the field to these changing conditions have helped us, be proactive in adjusting our operations and applying additional controls. I'm happy to report that we have not had any exceedances of those levels. And like I said, Frank will talk a little bit more about that here in just a moment. Next slide. So what is the real-time monitoring trends to date? So I want to talk a little bit, high level. If you want to look at those results, they are shared publicly. There are weekly, monthly, and quarterly data that are provided. You'll see the www.portsdemo.com website there. If you want to go look at that data, you're more than welcome to. It is very interesting that you can see the various changes in weather conditions and how things have been adjusted. And then also all that data will eventually get rolled up and placed into the annual site environmental report, which those are available at the second website. So I talked earlier about the independent air monitoring, and this is one that's really important to me as a community member, because it provides to the public an independent verification of the data that DOE is collecting. So Ohio EPA and Ohio Department of Health have both partnered with us to co-locate air monitorings, which they manage. They look at the data, and then we meet to evaluate our data against theirs to see to ensure that we have no anomalies. So as I said before, I'm happy to report that data recorded to date indicate that we have maintained a safe control of fugitive dust and also any other contaminants of concern that have been monitored. Next slide. So the next facility that will be slated for demolition is the largest of the process buildings, and that is the X333 process building. That facility is currently undergoing deactivation. So in that facility, you have much larger equipment than what was in the 326. So they have constructed a material sizing area. They are taking some of those components out, size reducing them, and removing some of the other hazards that are in that facility, preparing it for demolition. You'll see in the bottom left-hand corner some of the bundles that are being taken out of the facility. Those bundles are being size reduced and stored for potential future reuse. And we are preparing that facility to get ready for demolition in the not so distant future. As you can imagine, this is a much larger facility, so there will be some small differences, but we're also going to take an opportunity to take the lessons learned from the 326 facility and apply them to the future demolition of the other two process buildings. Next slide. So another piece of the DOE cleanup mission here at the site is the processing of the depleted uranium hexafluoride. So if you drive around the site, you'll see a lot of the cylinders sitting around. The majority of those are filled with depleted uranium hexafluoride, and that conversion facility is currently operating. They are converting DOE's inventory of depleted uranium hexafluoride that was produced during enrichment processing into a more stable uranium oxide for reuse. It is currently being stored, and we are preparing for subsequent transportation of that uranium oxide off-site. And we also are separating out the hexafluoric acid, which is also being reused. And then there will be subsequent disposition of those cylinders. Next slide. Next slide. So what does the future of the Portsmouth site look like? So in the very near future, the site reuse program will make available as parcels 2 and 3. So we're implementing a systematic approach to turn over these parcels of land to SODI for potential reuse for private industry. We've already transferred parcel 1, which is about 80 acres, which you see in the kind of in the graphic on the right. The next parcel to be transferred will be parcel 2, which is the green shaded area you'll see in the graphic on the right. It's approximately 227 acres. And then probably in the next year or so, we'll transfer parcel 3, which will be about 48 acres. So SODI is currently working to find industries and companies who are interested in using this land for reindustrialization. We've been hearing some good news about that, the potential reuse, and we're really excited to see what SODI can come up with. And from a departmental standpoint, transferring that land over to SODI in the local community is a win for the local community as well as the department. Next slide. So another thing we wanted to mention in tonight's meeting was the community commitment plan. This is something that's probably not been as well advertised as we'd like for it to be, but the community commitment plan is a part of the 4BWXT D&D contract here at Portsmouth. It has been for years. It focuses on 4 main areas. It focuses on things like educational outreach, regional purchasing. We promote small business, the use of small business. I'm happy to report that FPP has been utilizing their small business very effectively. It also includes community giving and economic development. So what the impacts of that have been, you'll see from the pictures on the right. We do things like the National Science Bowl. We have Science Day here on site. We've essentially affected 16,000 students who have participated in educational outreach programs. That also includes our ACER program. So if you ever do read one of the ACER reports, we find a local high school, they get involved, they are able to review the data, they work with the Ohio University, and they draft a summary report of the ACER report. It's written very well. It also is a great program because it creates well-informed community stakeholders via high school students. So wonderful program. I'm happy to report that $550 million has been committed to local companies for goods and services. $2.9 million has been donated by 4BWXT and their employees to local charitable organizations such as the United Way, the YMCA, and many, many others. $4.9 million has been invested to create and retain jobs right here in our local community, and that's just since 2011. So this is a big deal not only for the department but also for our site contractors, and it's an expectation for subsequent site contractors as we move forward with the demolition and deactivation. Next slide. So I think that's the end of my presentation. So Frank Johnston will now be sharing with you some of the 326 air monitoring data results. Thanks.
Okay, thank you very much. I wanted to present some of the air monitoring data that we've collected that really attempts to answer the question, given all the planning and all the design and all the controls that we've implemented, try to answering the question of how we've done relative to our air emissions from a very large demolition project such as the 326 facility. So this slide's a little bit about me. I won't go through that much. I have 37 plus years of experience in the environmental field, 32 of which is really on Department of Energy sites like this in environmental remediation and in D&D. A lot of experience in environmental management, environmental compliance, meeting all the rules and regulations that have to be met on projects like these, and have a decent amount of experience in remedial designs, air emission control systems, and industrial and wastewater treatment facilities. Next slide, please. So you're going to see this this type of map quite a bit here tonight. On the right-hand side is the Portsmouth property, and the red outlines the property boundary. And then on the left, you'll see another, it's the same windrows that Dr. Higley had presented that shows for 2021 what our prevailing winds were from what direction and what intensity they were. This chart, this slide is really attempting to show all of the air monitors that we have in place, and it is in a layering aspect, meaning that we have air monitors very close to the project-specific air monitors. We have additional air monitors throughout the Portsmouth property that are removed from the project and would be measuring not only project impacts but also cumulative impacts from all the site operations. And then we also have property boundary and off-site monitors that help us understand what the impact to our neighbors and community are. Next slide, please. Jeremy did a good job of introducing the real time, and I'm going to jump into the data here in just a second. I do want to mention that we are monitoring real-time data in real time. We get, anytime we have an excursion, we get email alerts to the project, to people like myself and to others, so that we can react immediately to the on-ground conditions that we're experiencing. It is really the first line of defense. We are very conscious of the weather conditions as well. I think we have 2 weather stations that we monitor wind speed and at a variety of heights. So we use this real-time data to really guide on a daily basis implementing the D&D of the 326 facility and other remediation projects. Next slide, please. So as I said, we're going to kind of jump right into some data here. This is the real-time particulate matter data at the PM10 level, which is at the 10 micron level. And these are from monitors that are around the 326 boundary. The overarching philosophy here is we want to keep whatever contamination there is in the project boundary. So if we are maintaining safety within the project boundary, then we have good assurance that we're not having any kind of adverse impact upon the property boundary and upon our neighbors. So this chart I will show talk about 3 distinct lines. The important line is the red line right in the middle. That is the National Ambient Air Quality Standard for particulate matter. It's 150 micrograms per cubic meter, and we've adopted that standard at the property boundary as the standard that we want to meet. But we're measuring and comparing our real-time data at the project area to make sure that we're not having any impact on the property boundary. So the very bottom is the results that goes from about April 2021 all the way up through July 1 this year. I'm indicating there when the structural demolition started and when the structural demolition was completed. And you'll see this is a graph of the 24-hour averages of the particulate matter over that entire duration. And all the controls that we've been able to put in place and react and the building, and the management practices that we've put in place have been effective in keeping that fugitive dust, that particulate matter in the project area. And it has been compliant with the standards that we have adopted. The 2 lines underneath that red line are action level lines. If we happen to have a daily exceedance of any of those action levels, we pause the project, we regroup, we try to understand what might have caused that, and then go forward. But all the data that we've collected so far has been below even those action levels. Next slide, please. So in addition to the project boundary real-time PM monitors, we have PM monitors at the 5 Department of Energy, Ohio EPA co-located monitors. or monitoring stations. So this chart is showing what the results of the real-time recordings for PM10 data is at these stations. Now again, at the very top, you'll see the red line. That is our 150 microgram per cubic meter National Ambient Air Quality Standard. And then you will see the chart at the bottom then shows the 24-hour averages of PM data from about February 21 through, again, July 1st, 2022. Now, these monitors, and there's a slide, a few slides I'll be able to show you that where these monitors are located, but these are away from the project, the 326 demolition project itself. So it would not only measure impacts from the demolition of the 326 facility, but it would also be measuring any other sources of particulate matter, fugitive dust from other site activities. So this is just showing again that we are doing, I think, very well in controlling fugitive dust and keeping the particulate matter controlled. Next slide, please. So another real-time monitor that we use is an ICAM that measures in real time radiological measurements such as alpha contamination. This is a chart that attempts to show where our readings for alpha have been. This is another control that we have in place to ensure not only the safety of our workers, but as I said, that we're being safe within the project boundary. We have good assurance that we're not impacting the property boundary in any adverse way. At the very top is the limit, 0.8 DAC hours. That is a limit established by our radiological engineers for the safety of our workforce. And the real-time measurements that we take are compared to that level. If we happen to exceed that, and the chart below shows that we have not, but it is alarmed, so that if there is any kind of exceedance, we have an alarm where our folks are then removed from the facility, and again, we pause work and try to understand what happened. But the data below is showing that good performance. We've had nothing approaching that particular limit. I've also included several call-outs just to kind of give an idea of how the alpha contamination and to some degree the particulate matter contamination we just talked about has been reacting through this time period of between April of 21 through the middle of July. You'll see at the very left when the demolition of the 326 facility began and loadout operations. At the very right then is when demolition has been completed, and that was completed on June 10th of this year. And then some other call-outs, we see when we had some hot weather, you'll see we have increased air movement that can impact particulate matter as well as alpha contamination. I've identified there where we've added an additional dust destroyers to help apply the misting and the fixatives on the debris piles and on the demolition as it was occurring. I am indicating where we suspended loadout operations. That was about the December timeframe, and that's simply because the on-site waste disposal facility closes basically from the middle of December through the middle of March. So these data are showing that, again, that our controls have been effective and have been compliant and have protected our workers. Next slide, please. So this is, the bottom left is a picture of one of those dust destroyers. This is applying fixative to a debris pile. And the main picture there is taken very shortly after the completion of structural demolition. And in fact, I think Jeremy's presentation had maybe a little updated picture. But this is showing all the debris piles that we are reducing and will be transporting up to the on-site waste disposal facility for treatment. The green tint that you see, again, is that fixative that has been applied. We are applying that fixative and water misting on a daily basis, and when the need arises based on real-time data that's measured. I'll pause right here just to say something. Even though structural demolition has been completed, we are continuing to do all the real-time monitoring and all the air sampling that I'll discuss later. We are continuing all of that until all this debris has been size reduced and removed from the 326 slab. Next slide, please. We talked about the real-time monitoring that we have done or are doing. Let's talk now a little bit about the sampling that we are doing at a variety of the sampling stations across the port's property and our property. One of the first things that was important in designing any monitoring program is really to understand what the contaminants of concern were. The 326 facility went through an extensive deactivation program from 2011 through 2020, where hazardous waste were removed, asbestos abatement was conducted, PCB liquids were removed, oils were removed, hazardous waste were removed. But even after removing all of that, there was a recognition and that due to the operational history of the facility, that there was still residual contaminants remaining. There's also contaminants that are just part of the materials of construction. The concrete that was in the facility, the structural steel, the paints, ductwork, those types of things that there are within those building materials, certain contaminants that can be imparted to the environment during a demolition project. So in researching that and understanding all that, we were able to develop a contaminants of concern list, a pretty extensive contaminants of concern list that included not only non-radiological contaminants such as heavy metals and asbestos and volatile organic chemicals and polychlorinated biphenyls, PCBs, but also radiological contaminants such as uranium and technetium. Next slide, please. So with an understanding of the contaminants of concern and as the design of the demolition was progressing, and as part of that design, we implemented a fairly robust air modeling effort to understand what the impact of this demolition project was going to do, as well as all the other projects. This air modeling effort looked at individual projects, but also looked at the cumulative impact from all the projects, including the 326 demolition, the excavation of the landfills and plumes, the operation of the OSWDF. So it was a very robust modeling effort to understand what our impact might be on the property boundary. This report was peer-reviewed both by an independent expert that Floor BWXT retained, as well as an independent expert that DOE had retained as well. So it went through an extensive internal review by our company and by the department, and then this was actually submitted to Ohio EPA, and they concurred with that modeling report on May 20th, 2020. That model included air emissions calculations. It included air dispersion modeling assessments. And I think it gave us, the department, and Ohio EPA some assurance that we would be able to comply with all of the requirements under the Clean Air Act, as well as the requirements that we're obligated to meet under the Department of Energy rules and regulations. Next slide, please. So here's our graph again of the air monitoring locations. You will see that there are 8 locations associated with the 326 demolition. There are 18 locations where there are Department of Energy and Ohio Department of Health co-located stations, and these are where we do our radiological ambient air monitoring. And then there are 5 locations where the Department of Energy and Ohio EPA have co-located monitoring stations. Next slide, please.
No, bitch, you don't like me.
Jeremy talked about what I believe to be a very good program where the Ohio Department of Health and Ohio EPA teamed together to implement this air monitoring program that we're discussing today. The Ohio Department of Health and Ohio EPA provides a redundancy in the air sampling to confirm that our air emission impacts. It's an independent mechanism to evaluate the data that is collected, and it's just an increased level of transparency with the state regulatory agencies as well as our stakeholders and our neighbors around the site, hopefully to give confidence in that all the data that we are collecting and what it means. Next slide, please. So these are some examples of the air monitoring stations that we're going to be talking about here. On the left is an example of the Ohio EPA Department of Energy co-located monitoring station. There are 5 such stations around the site. This is where we monitor for the non-radiological parameters. Data is gathered, analyzed, and validated from Ohio EPA's perspective, independent of DOE. Department of Energy gathers, analyzes, validates their data. Ohio EPA does the same to their data. Both sets of data are published quarterly. I will say as we go further that the data that I'm presenting today is the data from the Department of Energy sampling that's being conducted. In a similar manner, on the right-hand side is the Ohio Department of Health and Department of Energy co-located stations. There are 18 such stations. This is where we monitor for all the radiological contaminants. We also monitor for fluoride. I've asterisked that only to indicate that the Department of Energy continues to monitor for fluoride, but the Ohio Department of Health does not monitor for fluoride at these locations. Similarly, the data that is gathered, analyzed, and validated independent of DOE, and the data are published quarterly. And again, we will be presenting today only the Department of Energy radiological data. Next slide, please. Let's talk first about the non-radiological sampling results that we've had to date. Here is our map that shows the 5 locations of where these stations are at. You'll see relatively in the center of that map in a red highlight of where the 326 facility is, so you can kind of understand in relation where these air monitoring stations are. So we monitor for heavy metals such as antimony, arsenic, chromium, mercury, and all these heavy metals are sampled on a weekly basis. We also sample at these locations volatile organic compounds. The primary one that we are concerned with is trichloroethylene, which was commonly used as an industrial solvent, essentially throughout the entire operational history of Portsmouth. Volatile organic compounds are also sampled weekly. And then we also sample for fibers and asbestos fibers on a weekly basis at these locations. Next slide, please. So to understand and put into context the sampling results that we get, we have developed called a maximum acceptable ground level concentration. This standard is what we use as the protective level for all of these heavy metals and volatile organic chemicals, and it's applied at the property boundary itself. The MAGLIC is a calculated value based on exposure information from OSHA and the National Association of Industrial Hygienists, as well as operational assumptions on our demolition activities and other remediation activities. This MAGLIC is established for the non-radiological parameters, and as I said, it's applied at the property boundary itself. All the analytical data that we do collect then is compared to the individual MAGLIC calculated for an individual contaminant. The use of the MAGLIC and the associated calculations were presented in the air modeling report that we provided to Ohio EPA. Next slide, please. So this chart is going to be a little bit difficult to read, I recognize. What I'm trying to capture here is graphically the results of all the data that we have collected. So let me explain this just a little bit to hopefully so we can all understand what I'm trying to present here. At the very top is the list of the contaminants concerned and their respective MAGLIC, the respective maximum allowable ground level concentration. That is the protective level. Across the column to the very left is the individual air monitoring stations. And then the circles that are being shown here are indicating the maximum detection as a percentage of that protective level at each of these stations. So, for instance, if you looked at a contaminant, beryllium, which is the third one over, and if you look down at station A51 in blue, you would see that the maximum detection of beryllium at that location was 17.7% of the protective level. That's one of the larger ones. As you look at all of these based on percentage, if you look at all of these circles and all these percentages, we're seeing just fractions of the protective level at these air monitoring stations. And again, the MAGLIC we are applying at the property boundary itself. The data that we've collected that's internally and somewhat removed, in a couple of instances pretty close to the property boundary, fraction of what that protective level is. Next slide, please. This is a similar slide, but these are the average of all the analytical detections. The previous slide was the maximum detected. This is the average of all the analytical detections for these contaminants concerned. So really the takeaway from the last two slides is that the heavy metals and the TCE are well below the protective level that has been established and we're comparing our data to. That gives assurances that our emissions are compliant and are safe.
That's what we wanted to be when we grew up.
Next slide, please.
Our answers were things like astronaut.
I did mention asbestos. We do not have a MAGLIC for asbestos, but we do monitor for asbestos on a weekly basis. Actually, what we do is that we monitor for fibers, and then if we would happen to have any detection of fibers at these locations, then we would implement and send off-site for analytical evaluation to determine if any of those fibers are asbestos fibers. Department of Energy uses for these analyses, and I will say that these are in addition to all the asbestos monitoring that is done within the project boundary or at the project boundary by our industrial hygienists for the protection of our workforce. All the samples that we do for asbestos, like all the other samples, are sent to an independent laboratory for analysis. And we have not detected asbestos fibers at any of these monitoring locations. which indicates that our asbestos controls prior to demolition, all the abatement activities, and all our current activities have been protected through asbestos. Next slide, please. So now we'll talk a little bit about the radiological monitoring that we are conducting. And this is a map that shows where those air monitoring stations are. Some are on-site, some are very near the property boundary, and some are off-site. Again, in the middle of that diagram, you will see where the 326 facility is so that you can kind of have a relation of where these air monitoring stations are compared to the 326 demolition project. So at these locations, we monitor for a variety of radiological parameters. We monitor for transuranics, including americium, several plutonium isotopes. We monitor for thorium isotopes, transuranic monitored, sampled on a quarterly basis. We also monitor for total uranium and several uranium isotopes, and those are sampled on a monthly basis, as well as technetium-99. Next slide, please. So for transuranics, and this is the second periodic table you'll see tonight, transuranics are just elements that are heavier than uranium and are listed after uranium on the periodic table of the elements. And you will see at the very bottom of the periodic table where neptunium, plutonium, and americium show up on the periodic table of the elements. Isotopes of neptunium, plutonium, and americium have been continuously monitored at the ambient air monitors in and around the Portsmouth site since at least the mid-1990s. There have been occasional detections for transuranics at these locations and reported in the annual site environmental reports, but those detections have been very much below the regulatory limits that have been established and compared to during the last 2+ decades. Next slide, please. This is a chart of transuranic data. And the punchline that right off the bat is that we have not detected any transuranics at any of these ambient air monitoring locations beginning of the demolition through the data that we have currently are through April of 2022. I'll explain this chart just a little bit more because you're going to see this for some of the other radiological parameters. Bottom, on the horizontal axis of this chart, you will see listed the air monitoring stations. And they're listed from the ones that are closest to the 326 facility to the furthest, meaning the A52 is the closest to the 326 demolition site. A37 at the very right then is the furthest away from the demolition site. Slide, please. So this is a chart of thorium isotopes. Again, the horizontal axis is showing the air monitoring stations from closest to furthest away. But I'm showing here the thorium data at two different scales. The first larger chart shows the thorium data that you wouldn't be really able to see it because it's barely above zero. We are showing what the derived concentration standards are for the individual isotopes for thorium-230, 232, and 228. But like I said, the actual analytical data on this scale would be shown really just at zero. But what we've included here is an inserted chart at a much smaller scale showing what those analytical detections are. So it's just trying to give a little bit more transparency in what we're seeing, but all of the detections that we have seen for thorium are far below the individual derived concentration standards that have been established. These are data that have been collected from essentially the beginning of demolition through April of 2022 is the most recent data that we have available. Next slide, please. This is a similarly structured slide, and this is for total uranium. We've established, I'm showing here the derived concentration standard for uranium-238. The data that you'll see in the big chart from A52 through A37, again, right around zero, but we've included an inserted chart at a smaller scale to, again, put additional transparency as to what the actual data we are seeing is. And this is showing the maximum detected uranium concentrations that we've seen at these stations from the beginning of demolition through April of 2022. Next slide, please. Lastly, this is a chart for technetium-99. At the very top, you will see the derived concentration standard as 2,000 picocuries per cubic meter. And again, at that scale, all the data, the maximum detections that we have seen are all hovering right around zero. But again, we've included an inserted chart that is showing that data at a much smaller scale to show the detections, the maximum detections that we have had at these individual stations. This data is also a time span from just before demolition started through April of 2020. Next slide, please. In summary, what we're seeing from this data is that DOE data, these co-located air monitoring stations with Ohio EPA and ODH, are consistent with what the regulatory agencies have been measuring. It's not going to be exact, but it is very consistent with what they have been measuring. There's a couple websites that's listed below where you can actually see the data, be able to compare the data, to see, from time to time there are anomalies, but by and large, all the data that we have been collecting has been very consistent with what Ohio EPA and Ohio Department of Health has seen. Also seeing, just from the results of the data, that we have all our results are not approaching any regulatory limit. We're not indicating any kind of adverse impact at the property boundary or beyond the property boundary, that includes our neighbors and other stakeholders. I did mention some websites. These websites, Department of Energy, Ohio EPA, and Ohio Department of Health, all maintain their own websites. Department of Energy's website is the Pegasus website. So all these air monitoring data that has went through the verification and validation steps have been uploaded and is there and can be looked at and evaluated. That ends my portion of the presentation, and I will turn it back over to our host.
Who's your favorite?
Hey, thanks, Frank. And thanks for your presentation and sharing that information. Walk us through all the specific details of what's going on with the air monitoring and the data collection and understanding the data. Also want to thank Mr. Jeremy Davis for his update, the activities taking place at the Portsmouth site, as well as Dr. Kathy Igley and her the presentation she gave to kick us off tonight on air monitoring risk and putting that in context so we have a better grasp of just what we're dealing with here tonight. So the original plan was to take a brief break at this point, but it looks like we have really just one question that's come across. So we did have one question, so we're going to just plow ahead. We're going to acknowledge the question and talk about how we're going to get an answer for that. and then we're going to open up the meeting for public comment. So, Frank, Jeremy, the one question we did have came in on the chat, and Dr. Higley is working on an answer for us. And as soon as she gets that, we'll either address it Thursday or we'll post it on the portsdemo.com website in a written form. The question had to do with work schedules. If they're greater than the standard 40-hour work week, in this case, it looks like work schedules are at 58 hours per week. How does that increase the exposure risk for potential employees? And so Dr. Higley is working on an answer for that for us, and we'll be able to reply to that question shortly. So with that, we're going to slide forward to the public comment portion of tonight's meeting. If you would like to participate in the public comment portion, I ask you to find the reactions button. It's on your desktop or tablet, phone, whatever mechanism you're using. It's got the little emojis, emoticons that you can click on. It also has a hand gesture and it'll allow you to raise your hand. So if you can click on that, recognize you and see who has raised their hand, and we'll open up your mic for public comments. We'll give you just a second if anybody participating at home would like to share their comments. All right, seeing none at this point. We will do a similar presentation on Thursday night. Thursday at the same time, same location. You can find us at portsvirtualevent.com. But if you have questions between now and then, please don't hesitate to share those with us. Donnie, can you throw up the email address for us one more time? ports-demo-questions@pppo.gov. If you have any questions, please don't hesitate to email those to us at any time. And if you just follow up to the questions that are already available, there you can find those at portsdemo.com. Thanks for your time. Thanks for being with us tonight again. Frank, Jeremy, Dr. Kathy, thank you for being with us. And we'll see you Thursday night.